Today we're looking at sample problems from section 10.3. 10.3 deals with permutations and combinations. Okay, we're going to start with number 2. We're going to refresh our memories on the formulas. In number 2 we have 12 permutations taken 5 at a time. So what we want is we want n factorial over n minus r factorial, if you remember, is our permutations formula for permutations of n objects taken r at a time. So that'll be 12 factorial over 12 minus 5 factorial. And we're going to do this the longer way. 12 times 11 times 10 times 9 times 8 times 7 factorial over 7 factorial. We can cancel those. So now we just need to multiply, and I am going to use my calculator to multiply what's left. We have 12 times 11 times 10 times 9 times 8. So 95,040 would be the number of permutations. Okay, in number 4, we're going to review the combinations formula. We're looking at combinations of 14 objects taken 6 at a time. Okay, and for our combinations, we want n factorial over n minus r factorial times r factorial. So in this case, our n is 14. We'll have 14 minus 6 factorial times 6 factorial. This one's going to be 8, so that's what I'm shooting for. 11, 10, 9, 8 factorial. 6 times 5 times 4 is 3 times 2 times 1. So the 8 factorials cancel. 6 times 2 will give us a 12. We have a 20 there, so that'll leave us with a 2. We have a 3 that'll go into 9. We have a 2 that will go into 14. So let me multiply what's left. We have 7 times 13 times 11 times 3. And I'm getting 3003. Okay, so those are our two formulas we want to remember if we're doing it by hand rather than using the calculator permutations and combinations keys. Okay, now the next one asks us to evaluate using the calculator, so let's just do one of these. We'll do number 10. Number 10 is combinations of 32 taken 12 at a time. So I'm going to go to our calculator and let me clear it. Okay, 32, and I want to go to probability under math, and I want combinations, so I want number 3, and taken 12 at a time, and I'm getting 225,792,840. 225,792,840. Okay, so that's a reminder of how we do it on the calculator. Alright, let's see if I can do 25,792,840 using the calculator. Okay, now we're going to go to some problems, and in the beginning they make them fairly easy. They divide them between, they separate out the combinations and permutations problems. So we'll start with number 16. These are dealing with permutations. 16 through 23 can be solved with permutations, even though the problem statements will not always include a form of the word permutation or arrangement or ordering. Okay, so in 16, placing in a race, how many different ways could first, second, and third place finishers occur in a race with 6 runners competing? Okay, because of the fact that first prize differs from second prize, which differs from third prize, this would be a permutation. Order does make a difference. So we have 6 runners, and we're choosing 3, the top 3. So we want 6 factorial over 6 minus 3 factorial, which is 6 times 5 times 4 times 3 factorial over 3 factorial, and that gives us 120 ways for our first, second, and third prize to be awarded. Moving on to 18. In 18, it says an automated teller machine requires a 4-digit personal identification number using the digits 0 through 9. The first digit may be a 0. How many such pins have no repeated digits? Okay, so we have a 0 through 9. That's 10 different digits. So it's going to be permutations of the 10 taken 4 at a time. Since we're not allowed to have repetitions, permutations can be used here. If repetitions were allowed, we would have to use the fundamental counting principle. So we're going to have 10 factorial over 10 minus 4 factorial, and that's going to be a 6. So 10 times 9 times 8 times 7 times 6 factorial. Okay, and I'm going to cancel those, so I need to multiply 10 times 9 times 8 times 7. And I'm getting 5,040 pin numbers could be made. Okay, turning the page, number 22. A security team visits 12 offices each night. How many different ways can the team order its visits? So in this case, we have 12 sites that are being visited, and all 12 of them have to be visited. So 12 factorial over 12 minus 12 factorial, and 12 factorial divided by 0 factorial. Remembering that 0 factorial is just a 1, we end up with 12 factorial. And again, I'm going to use the calculator to calculate this. All right. Okay, so we have 479,001,600 ways that they could schedule their visits. Okay, now we're moving into the section that goes over combinations, where we use combinations. We'll do 3 examples from that, so starting with 24. In 24, how many ways can a sample of 5 cell phones be selected from a shipment of 24 cell phones? Okay, so this is a subset. Doesn't matter what the order is, so we want 24 factorial over 24 minus 5 factorial, 5 factorial. 23, 22. This is 19, so that's where I'm headed. 21, 20, 19 factorial. 19 factorial. This is 5 times 4 times 3 times 2 times 1. And that's a 20. This is a, whoops, let me go back to, this is a 6, which will give us a 4. Okay, so it looks like we're multiplying 4 times 23, 4 times 23 times 22 times 21. And I'm getting 42,504. Okay, and I think I'm going to stop here, and we'll pick up in a separate recording the rest of the samples for this section. So I'm going to call it quits right now.